So now we take it up a notch. So we already know how to factor quadratics, and you know that quadratics have a squared, right? But then these don't look quadratic, right? I see x to the fourth. So these are what we call quadratic form, or sometimes I call quadratic-ish. They're sort of quadratic, and they're going to be solved the same way, where we set the equation equal to 0, then we factor. Then we set each factor equal to 0. Then we solve. Then we solve. So here you might say, well, how do I factor that? Well, same way as we did before, we say what times what gives you x to the fourth? X squared, x squared. What times what gives you positive 9 but adds to negative 10, right? Negative 9 and positive 1. Sorry, negative 9 and negative 1, right? Yeah. Can I factor that again? Sure. X plus 3, x minus 3, x plus 1, x minus 1, right? And if I set each of those factors equal to 0, here I'm going to get negative 3, positive 3, negative 1, positive 1. I'm just going to write that down. We would have to write all 4 of those little mini equations, but you get the point. So it's like quadratic, but quadratic-ish. You see it now, right? Next one here, x to the fourth would be, again, x squared, x squared. This is x squared minus 1, x squared minus 4. When you go to solve your mini equations, you don't have to factor them again. You could use our square root method that we talked about, right? You could add 1 to both sides, x squared is 1, add 4 to both sides, x squared is 4, square root, square root, square root, square root. What do you have to remember when you take the square root, right? Plus or minus. So plus or minus 1, plus or minus 2, which of course stands for 1, negative 1, 2, negative 2. And you're like, oh, that's great, but these other ones don't look quite as easy, do they? So these you can do, you have 2 choices. You can do substitution or what I call stone cold factor. Time depends on the problem. I'm going to try this one by stone cold factor. When you stone cold factor, a little trick is whatever the middle variable is what's going to go in each spot here. Because if you think about it, square root of x times square root of x is the square root of x squared, which is x, right? Numbers that multiply to negative 10 add to positive 3 is going to be positive 5 and negative 2. And then you can solve each of these, right? You got your mini equation here, you got your mini equation here. If I add negative 5 to both sides or subtract 5 from both sides, and here add 2 to both sides. Now this is a little bit different. I'm not going to square root both sides, I'm going to square both sides. Here I'm going to get x is 4. Here, I'm actually not going to get an answer. What? If you think about it from this step, a square root cannot equal a negative. And I know what you're thinking. What about imaginary numbers? Imaginary numbers are the square roots of negatives. Square root without a negative in front of it does not equal a negative. But sometimes people will say, well, I can just still square both sides and get 25, but if I plug it in, which whoever plugs it in, it's not going to work. So 3 times 5 is 15 minus 10, that doesn't equal 0. So you got to check your work, or you got to kind of look for that red flag right there that this one would have an empty set. So only one solution there. All right, what about this one? T to the 1/3. So t to the 1/3. I'm going to stone cold factor it. I'll do my substitution for the next two. I'm going to take that as my variable. Middle variable, t to the 1/3 times t to the 1/3 is t to the 2/3. This is going to be negative 5 and positive 2. So t to the 1/3, if I can jump ahead here, is going to equal 5, and t to the 1/3 is going to equal negative 2. What is the 1/3? You might not know that the 1/3 power is the cube root. Do you know that? That's the cube root, and you could cube both sides. Cube both sides. So here our final answer here is going to be t is 125, or t is negative 8. What is this substitution method you speak of? Well, sometimes you just want to get things a little simpler looking. So you choose a letter like, let's say, I don't know, W. Let W equal the middle variable. then this variable is always going to be the square of that original variable. So it's w squared plus 4w plus 4 equals 0. And then this can be solved here. It's going to be a double root. So here I get w equals negative 2. But I have to go back and replace w with the 7th root of y is negative 2. And that I can solve by taking both sides to the 7th power. So what is negative 2 to the 7th? Let me think about that. Negative 2 to the 5th is negative 32, 64. I think it's negative 128. Yeah. Or you can even leave it as negative 2 to the 7th. Last one here, I'm going to use again my substitution. I'm going to let w equal x squared minus 1. So this is going to become w squared minus w minus 2 equals 0, which factors w minus 2, w plus 1, w is 2, w is negative 1. But then I have to go back and plug that in. So either 2 equals x squared minus 1 or negative 1 equals x squared minus 1. If I solve this one, I get x squared is 3, so x is going to be plus or minus root 3. If I add 1 to both sides here, I'm going to have x squared is 0, x is plus or minus 0, which is just really 0. So you either can solve them by substitution or stone cold factor. Either way, it's that middle variable that's your key. Those are going to be a little tricky. I would suggest that you look at the key as you go on the homework, and it will get better.